Hi guys, welcome back to my channel. So in this video we're going to go over directional derivatives. However, this is the part 2 of this video. If you want to watch the part 1, I've provided the link to that in the description below. Okay, let's continue with this one. So in here we're finding the directional derivative of the given function at the point 1, negative 1, 2 in the direction of a given vector. Okay, and from the part 1 you guys know that this is the equation to find the directional derivative. First we find the gradient vector and then we dot product it with the unit vector. However, in part 1 we calculated since we were given the angle, so the unit vector we could calculate it as cosine of angle I hat plus sine of angle j hat, right? If we are given the angle, this is how we compute it. But if we're not given the angle, which is this case, so how do we calculate the unit vector? So for this we are using another formula, which is we take the vector itself and then we divide it by the norm of the vector. Okay, so this is what we're going to use. Wait, let me just write it a little neatly over here. Okay, so this is what we're doing in this problem. Okay, so we have our vector over here. So we just need to find the norm of the vector. So how do we find the norm of the vector? Do you guys remember how do we find the norm of the vector? It's pretty easy if you guys don't. So we're just going to square each component and then add them and then square root the whole thing. Right? So this is our vector. We're squaring each component, adding them, and then square root the whole thing to find the magnitude of the unit vector. Magnitude of the vector, I mean. Okay, so that's 36, 4, 49, 49, square root of 49, that's 7. Okay, so we have our magnitude of the vector here. So we have our vector itself over here. So we just need to find the unit vector now. So the unit vector is the vector itself over the norm of the vector. The vector itself is 6i hat plus 2j hat plus 3k hat, and then divided by the norm, what we just calculated. So this gives us 6 over 7 I hat plus 2 over 7 j hat plus 3 over 7 k hats. So this is our unit vector. We have just calculated our unit vector over here, but we're not done yet. Okay, we still have to find the gradient vector. We just found the unit vector. So to find the gradient vector, if you don't know how to find the gradient vector, I've made a video on that as well. The link to that video will be shown over here, so if you want you can click that out and check it out. So okay, so let's continue with the gradient vector. So to find the gradient vector, how do we do this? First we are going to take the partial derivative of the function with respect to x and I hat, and then partial derivative of the function with respect to y, j hat, and since it's a 3 variable function, we're going to differentiate it with respect to z as well, and k hat. And if you want, you can write it in a simpler way as well. You can simply say f of x I hat plus f of y j hat plus f of z k hat. It's the same thing. It's the same way of writing the same notation. Okay, so yeah. Okay, so I'm just gonna use f of x, f of y, f of z. It's just simpler. So let's find f of x first. And what's our function? So our function is written over here. So let me copy it from here. And I'm gonna paste it over here. Okay, so this is our function over here, and we are differentiating with respect to x. So since it's a 3 variable function, we're differentiating with respect to x. So the other variables, we keep it as a constant. So y and z over here are constants. So we're going to treat them as a constant. So y and z are constants. So we're differentiating only x. Okay, differentiating only x, that's just 1, so we don't write it. And then y squared, it's a constant, stays over there. And then we're differentiating only x, so that 2 brings down, so that's gonna be 8x. Y stays there because it's a constant, and z, it's a constant, so that goes to 0. Okay, now we are finding f of y. F of y means what variables are constant? It means x and z are constant. Okay, differentiating only y, treating x and z as a constant. Okay, so we're differentiating only y, the other variables we're not touching them because they're constants. All right, so okay, so we're differentiating only y. Okay, so it's going to stay over there, and then the z, it's a constant, so we put it as 0. And f of z. Okay, so let's continue with that. I'm sorry, I just got a phone call, so yeah. Okay, so we're continuing over here, and then y and z are constants over here, but we are differentiating with respect to z over here. So here it's x and y. X and y are constants. Okay, so x and y are constants. So every time we see z, we're only differentiating z. So this is the only time we see z. So that's going to be 2z. And these two are 0 because they are constants. Wait, why did I put a plus over here? Okay, so now once we have our f of x, f of y, f of z, we can put them all together to write the gradient. So that's my f of x, y squared minus 8xy I hat, plus f of y, which is 2yx minus 4x squared j hat, plus 2z k hat. Now once we have our gradient and we have our dot product, we can calculate the directional derivative. But see, here we are given the point as well, so we need to plug in the point within the gradient first to calculate the gradient at the point. So the point that is given to us is 1, -1, 2. So we're going to plug in into the gradient. So let me use the space below. It's getting messy over here. Okay. Let me pause the video and then I'm gonna write the equation over here a better way. Okay, so this is what I did. I just removed that thing over here and then put it over here. And I wrote it neatly. And where are we? So we are plugging in the point given to us in the gradient vector. So this is my x, this is y, and this is z, and we're just plugging in into the gradient that we just found. Okay, so y, that's -1, so we're going to do -1 squared times 8 times 1 times -1 I hat plus 2 times -1 times 1 minus 4 times 1 squared. 1 squared, that's simply 1, you don't have to write it. Okay, j squared times 2 times 2 times 2, that's 4. Okay, and then k hat. Okay, so if you calculate all this, so this should give you 9 I hat -6 g hat plus 3 k hat, and that's my gradient at the point. Okay, plus. So now once we have our gradient at the point, what is our next step? Our next step is to dot product it with the unit vector. Okay, so the unit vector we found was 6/7 I hat, 2/7 g hat, plus 3/7 k hat. So this is our unit vector. We're just going to dot product it with this one. So we have our gradient vector just 9 I hat minus 6 g hat plus 3 k hat. That's my gradient vector. Okay, we're going to dot product it with the unit vector that we just found. Okay, so that's 6/7 I hat plus 2/7 g hat plus 3/7 k hat. Okay, so how do we do the dot product? Okay, so we have to do 9 times 9/6, 9 times 6/7 plus, oops, that's a negative, I forgot. And then I have to do -6 times 2/7 g hat times g hat and 3 k hat times key hat, which is 3 times 3 over 7. And then this is going to be 9 times 6, 54 over 7, minus 12 over 7, plus 9 over 7. And if you calculate all this, that should give you 54 over 7. And that's your final answer. That's your directional derivative. I hope you guys found this video helpful, and thanks for watching. Bye!